Hi, today we're solving problem 53. We're shown the 10 ways of selecting 3 values from 5 values. So here, if we have 1, 2, 3, 4, 5 are our 5 values, these are the different ways to pick 3 out of 5. In combinatorics, to count how many there are, we use the notation 5 choose 3, which gives the number of ways to pick 3 values from 5, and this is 10. In general, we have this formula for calculating n choose r. But it is not until n is 23 that this value can exceed 1 million. And the first value that does is 23 choose 10. We need to find all of the not necessarily distinct values of n choose r for n between 1 and 100, which are greater than 1 million. One way to solve this problem would have been to use big integer and calculate this value for all possible n and r since we are given a limit. But let's get smarter. What we can actually do is keep track if a number is greater than 1 million or not, because we know that if a number greater than 1 million is added to another number, the total sum will be greater than 1 million. But where is this summation coming in? What we're going to use to calculate these values isn't going to be the formula. Instead, we're going to use Pascal's triangle. So with Pascal's triangle, you actually get a way to calculate these n choose r values really easily. Because the first top value is 0 choose 0, then you have 1 choose 0, 1 choose 1, then you have 2 choose 0, 2 choose 1, which is 2. So now we're in the 1, 2, 1 row, and 2 choose 2, and it continues. So then each row represents a different value of n. So what we're going to do is we're going to generate these 100 rows of Pascal's triangle, and then count how many of these are greater than 1 million. But here as well, we're not going to use any big integers because these values are going to get pretty big. What we're instead going to do is use an option. What this option is going to tell us is if it's sum, that means the value is still less than 1 million and we need to keep track of it to know when it does pass 1 million. But if it's none, it's already greater than 1 million. And anything added with that when we're generating the next row should also be none, representing that it's greater than 1 million. At the end, we just count how many are none. So let's get started. The first thing I want to do is create a way to generate Pascal's triangle. So I can create a def Pascal's triangle. And the way we're going to define Pascal's triangle is recursively, but in order to get a collection, we're going to use a really cool feature of Scala, which are streams. So with a stream, you can recursively define a lazy collection. So you can say how, given a value, how to get the next iteration, the remaining part of the stream, but it won't calculate that remaining part until it's requested. So we can define how the whole triangle would be generated, and since it's infinitely large, we wouldn't actually calculate that. But we can just say get the first 100 values in that triangle, and it'll be able to do that using just the recursive definition. So the way we're going to define it is we're going to take a current row, which is going to be a vector of option of int. So if it's sum, that'll be our value, and we know that any value under 1 million will fit in an int. So we're good there. And we're going to return a stream of vector of option of int. And what each value in the stream, each value here is going to represent one of the rows in Pascal's triangle. So now, how do we define this? Well, it's actually pretty simple. All we do when calculating the next row of Pascal's triangle is group every adjacent two values and sum them up. And we can do that super easily with Scala. So we can create a val next row, what I'm first going to do is add the extra ones at the end because it's going to expand. So I'm going to add 1, and I'm going to append this to. What I'm first going to do is I'm going to take current row, and so that I get those adjacent 2 values, I'm going to do sliding 2. So this will create us a sliding window of size 2. Now for every single value in the sliding window, I'm going to take a slid. So we need to add the 2 values of slid. The first thing we need to do is check if either of the values of slid are none. Because in that case, we just want to return none. Well, the way we can do that is we can check if there exists a value in slid such that it is empty. And is empty returns true when it is not defined. If one of them is empty, then we just return none because we know that the total sum will be greater than 1,000,000. Otherwise, we're going to calculate the sum, which is going to be the first value of slid plus the last value of slid. And what we need to do with our sum is first check if it's greater than 1,000,000 because that's when it turns into a none. So if our sum is greater than, we need greater than, not greater than or equal to, it's greater than 1,000,000, then we want to give none. Otherwise, we want to give sum with the sum, so we can keep track of that. And sliding is actually giving us an iterator of values, so this map will also return an iterator of option of int. We need to convert that to a vector, so let's do that. And the last thing is adding the 1 at the end, which we can add here. So now we've calculated the next row in Pascal's triangle. All we have to do now is take our current row and tell Stream that the definition is taking our current row, and current row is going to be followed by, and in Stream you do that by doing pound colon colon. It's going to be followed by Pascal's triangle with the next row. And next row's type isn't good because we forgot to wrap the ones in options. So here we have sum1, sum1. And now we have our Pascal's triangle. So you can go ahead and print Pascal's triangle. We start with a vector of sum of 1. So that's our first value. And let's take the first 3 rows. So now we can go ahead and run this. So we actually need to do this and convert it to a array or some value. So right now it's being lazy and not calculating it. Here we need to actually do that. Let's do, and we can make string with a new line in between. So now we should see our Pascal's triangle. So we see 1, 1, 2, 1, 1, 3, 3, 1. So we have our Pascal's triangle working. Now, all we have to do is count how many of the values in the first 100 values of Pascal's triangle are none. So we can print ln. All we have to do is do Pascal's triangle. We start with a vector of sum1. We're going to take 100 values of this. We're going to flatten this because when we take 100, we're going to get a stream of vector of option, but we only care about iterating over these options, so we can flatten these 2 collections. So then we just get here a stream of those options. And now we need to count how many are none. So we're going to count the ones that are empty. Now I can go ahead and run this, and we get our answer. So that's it for problem 53. I'll see you next time when we solve problem 54.